LangChain is an amazing framework that allows you to build apps such as question answering and RAG. In this video, we build a simple RAG app locally and for free. RAG is nothing but a technique for augmenting LLM knowledge with additional data. First thing first, let's take a look at the topics we'll cover. To build this app, we'll use two main components. These are indexing and retrieval. To index, we'll first load our data with document loaders. And then we'll split large documents into smaller chunks with text splinters. The next step we'll do is index our splits and store. To do this, we'll use vector store and embedding. After that, based on user input, our model will retrieve relevant splits from storage using a retriever. Lastly, our local model will generate an answer using a prompt that includes the question and the retrieved data. Nice! We've seen the topics we'll cover in this video. Let's go ahead and start by setting the virgin environment. To do this, let's go to the VS Code editor and open our terminal. First, we're gonna create a virgin environment with Conda. Let's write Conda create -n. Let's name Gen AI. I already created this. After that, we're gonna activate this environment. Let's do this. Conda activate Gen AI. Okay, our environment is ready to use. What we're gonna do now is install the tools we'll use. To do this, let's create a requirements.txt file. We're gonna click on the new file and then name it requirements.txt. After that, let's write the tools we'll use here. We're gonna type LangChain and then LangChain community. To get a prompt about RAG from Hub, we'll use LangChain Hub. LangChain Hub. As the vector database, we leverage the ChromaDB. ChromaDB. Lastly, to extract data from a website, we'll use the BS4 tool. For now, these tools are enough to build the app. We're gonna now install this. To do this, let's use pip. Let's write pip install -r requirements.txt. There you go. Our tools are ready to use. To write our codes, we're gonna create a notebook file. Let me click on the new file and then give a name. rag.ipynb. Yeah, our file is ready. To work with this notebook, let's select our kernel. After that, let's click Python environments and then click on the Gen AI. That's it. Our notebook is ready. We're gonna use a local model with Ollama. Ollama allows you to run open source LLMs such as Mistral and Llama 2 locally. All you need to do to use these models is download this tool and then install it on your computer. To download, go to the Ollama website and then press the download button. After downloading, install it on your computer. After installing, you can use this tool in your terminal. To see whether this tool is installed, just type Ollama and then press enter. There you go. To load a model, type Ollama pool and then type the model Mistral. This is simple, right? The model we'll use is Mistral. To see the installed models, use Ollama list. There you go. The model we'll use is Mistral. The embedding model we'll leverage is Nomic Embed Text. I already pulled this model. Cool. We've seen the models we'll use. Before initializing the model, let me use the LangSmith. Note that LangSmith is not needed, but it is helpful. LangChain allows you to track our steps. To use this tool, we're gonna leverage the OS module. First, let's import this module. Import OS. Next, we're gonna set LangChain tracing as an environment variable. os.environ. Let's write LangChain v2 equals true. After that, all we need is to enter the LangChain API key. To do this, we're gonna use the getPath tool. First, let's import this tool. Import getPath. Next, let's set the API key. Host.environ let's pass LangChain API key equals, it's gonna be getPath dot, let's call the getPath method. Now we can enter the API key. Note that you can get the API key from the LangChain website for free. I'll leave the link to this website in the description below. Let me copy the API key and then press enter. Awesome! Our API key is ready to go. Let's go ahead and initialize the model. First, we're gonna import Ollama from LangChain. From LangChain community dot LLMs import Ollama. Next, let's initialize the mystery model using this class. LLM equals Ollama model. Let's set Mistral. For the result to be deterministic, let's set temperature equals 0. Nice! Our model is ready to predict. To test this model, let's generate text. Let's say we're gonna get the information about LangGraph. To do this, let's ask the model what LangChain is. Let's type LLM. Let's call the invoke method. Let's pass what is LangGraph. As you can see, the model could not give the right answer. It said LangGraph is a large-scale graph database specifically designed for NLP, and it was developed by Microsoft Research. That is the wrong answer. Since language models are trained on massive data, they can sometimes generate false information. To overcome this problem, we're gonna use the RAG technique. What we're gonna do now is load the blog post contents about LangGraph. This blog post explains what LangGraph is. For RAG, we're gonna use this post. First, let's load this post using document loaders. Now, we're gonna import the web-based loader class from this module. From LangChain community dot documents loaders import web-based loader. Next, let's load this post using this class. First, let's initialize an object from this class. Let's say loader. Let's call the web-based loader class. Let's set the web path parameter. Let's pass the link. Now we can load the web page using this object. Let's say docs equals loader dot load. That's it. Our data is ready to use. If you want, you can print this data. Let me show this. Let's say docs. Let's select the first element. Let's write page content. There you go. Here is our text about LangGraph. We can also take a look at the length of this text. To do this, we can use the len method. Let's write len and then let's pass docs page content. There you go. Our loaded document is over 12,000 characters long. This is too long to fit in the context window of many models. To overcome this problem, we can split the documents into chunks for embedding and vector storage. This should help us retrieve only the most relevant bits of the blog post. To do this, we're gonna use recursive character text splitter. This class helps us recursively split the documents using common separator like newlines. First, let's import this class. From LangChain text splitters import recursive character text splitters. Next, let's initialize an object from this class. Text splitter. Let's call recursive character text splitter We split our documents into chunks of 1000 characters with 200 characters of overlap between chunks. First, let's set the chunk size parameter. Chunk size equals 1000. Let's set chunk overlap. Chunk overlap. Overlap is nothing but a small amount of text between chunks that helps preserve context. Let's set 200. We're gonna set at start index equals true. This helps us add a metadata attribute. At start index equals true. Nice! We initialize an object to split our text into chunks. The next step is to apply this class to our text. Let's say all splits equals, let's call text splitter. Let's write split documents. Let's pass our docs variable. There you go. Our text is split into chunks. We can look at the number of these chunks using the len method. Len, let's pass all splits. There you go. We can also see the length of each chunk. To do this, let's write len, let's pass all splits. Let's pass the second element. Let's write page content. There you go. As you can see, the length is less than 1000. What we're gonna do now is index our 21 text chunks. This helps us search over them at runtime. To do this, we're gonna embed the contents of each document split and insert these embeddings into a vector database. The embedding model we're gonna use locally is the Nomic embed text model. First, let's import this model with Ollama. From LangChain community, import embeddings. Next, let's get the model using this method. Let's say embedding equals, let's call embeddings dot Ollama dot Ollama embeddings. Let's pass model equals Nomic embed text. Okay, our model is ready to embed. The vector store we're gonna use is Chroma. Let's import this vector store. From LangChain community dot vector stores, import Chroma. Next, let's initialize an object from this class. Let's say vector store equals Chroma. Let's call the from document method. Now we're gonna pass our documents and embedding. Documents equals, let's pass the all splits variable. After that, let's set embedding. Let's pass the embedding variable. Cool! Our vector store is ready to use. Note that we wanna create a simple app. This app will take a user question, search for documents relevant, and then return an answer. Now, we need to define our logic for search over documents. We are lucky that LangChain defines a retrieval interface. This interface helps us return relevant documents given a string query. The most common type of retriever is the vector store retriever. This class uses the similarity search technique. Let's create a retriever. Let's say retriever equals vector store as retriever. Let's set the search type parameter. Let's pass similarity. After that, let's specify tab key. To do this, let's set search quarks. Let's pass K6. Nice! Our retriever is ready to use. Let's explore how it works. We wanna know what LangGraph is. Let's take a look at documents related to this text. To do this, we're gonna use the get relevant documents method. Let's write retriever. Let's call the get relevant documents. Let's pass what is LangGraph. There you go. Here you can see 6 documents related to the text. Our model will take the text and then search over these documents and then return the answer. It's time to generate the output. To do this, let's put it all together into a chain. This chain will take a question, retrieve relevant documents, construct a prompt, pass that a model, and then parse the output. That's it. We already created our mystery model with Ollama. Now, let's get a prompt for RAG from the LangChain prompt hub. To do this, let's import the hub. From LangChain import hub. You can find a lot of prompts in hub. We're gonna get a prompt for RAG. Let's say prompt equals hub dot pull. Let's pass rlm RAG prompt. You can see this prompt in hub. Here is our prompt. There are 2 variables. These are question and context. This means that we're gonna specify these variables for RAG. Now let's create a chain. Let's say RAG chain equals. First, let's set the context. Context. Let's pass our retriever. After that, let me use pipe. Now we're gonna join the relevant documents. To do this, let's create a function. Let's say def. Let's name format docs. Let's pass docs. Let's set return \n \n. Let's call the join method. Let's pass doc dot page content for doc in docs. Cool, our function is ready to use. Next, let's write this function. Format docs. Now we're gonna set the question variable. Question. It's gonna be runnable pass true. To use this class, let's import this from LangChain core dot runables import runnable pass through. Let me fix this class. This class allows to pass input unchanged. Next, let's set our prompt. Let me use pipe and then let's type prompt. And then let's type our model. LLM. We wanna see output as a string. To do this, we're gonna use the str output parser class. First, let's import this class from LangChain core output parsers import str output parser. Next, let's add this class to our chain str output parser. Cool, our chain is ready to use. Now we're gonna pass our input this chain. Let's write RAG chain. Let's call the invoke method. Let's pass what is LangGraph. There you go. Here you can see the correct information about LangGraph. The model returned the relevant answer for our input. That's cool, right? Let's ask another question. RAG chain. Let's call the invoke method. Let's pass what is LangGraph used for. There you go. Our model look at the relevant documents and return the output. You can monitor all the steps we performed on LangSmith. Here is the Landsmith dashboard. You can see our input and output. Here is our input. What is LangGraph? Here you can see the output. You can easily track your project here. This is cool, right? Yeah, that's it. In this video, we covered how to build a RAG app with LangChain step by step, locally and for free. Let's go over our codes. First, to track our codes, we entered Landsmith. Next, we initialized our model with Ollama. After that, we loaded our data about LangGraph. And then, we split this data into chunks. To search the model's response, we indexed using an embedded model with Ollama. To index, we used the Chroma vector store. Lastly, to generate an output based on our input, we created a chain. We passed this chain to our input, the local model, and str output parser. When we asked output LangGraph to our model, the model returned the correct answer. This is simple, right? Note that the link to this notebook is in the description below. Hope you enjoyed. Thanks for watching. Don't forget to subscribe, like the video, and leave a comment. See you in the next video. Bye for now.